Hello, and welcome to the first lecture of the Introduction to Data Science module, Unit 1. That's Scientific Computing and Python for Data Science. Uh, the first module of the course, or the first portion of the course, will be dedicated to programming in Python and developing our familiarity with how to construct data structures, load in data, um, and create all the kinds of objects and functions we might need to do data science. We'll also discuss how to import external packages for doing data science as well, at which point we'll transition into the data wrangling module um, and get more into actual working with data. As mentioned in the introductory video, which hopefully you've watched by now, all the course content is on your Jupyter Hub notebook server under the data course directory. And today's lecture and for the beginning of the course will be in the Python directory. Before we get into Python, I'm just going to open up this PyIntro notebook. Similar to your control panel for Jupyter Hub, there's a lot of useful information here, such as the rough course syllabus. This may change over the duration of the course depending on the pacing and what students are struggling with or excelling at. But you can find a syllabus here. There's also a brief overview of how Jupyter Notebooks work and how Jupyter Hub works. So this is another resource in addition to the introductory video that was included in your welcome email and is also linked from the homepage on the control panel. There's also notes about the fact that many of the notebooks containing the lecture notes also contain exercises for you to engage with throughout the lectures, and we'll see some of those today. So with that out of the way, let's talk about computer programming and programming in the Python language. I'm going to execute just these top cells in this notebook. I'm also going to clear the output of this notebook. So I'm going to execute these top cells. These cells contain some boilerplate code you'll find in a lot of the notebooks. It just makes sure that the notebooks function the way we expect and all graphics we make display in a consistent way across the notebooks. We'll be discussing the precise meaning of statements like imports later in the class. But for now, we'll just run those and forget about them. So let's begin by first discussing what a computer program is. There's a number of different languages for writing computer programs, and these various languages have different perspectives on how computer programs should be organized or thought about. But at its simplest, computer programs are a list of instructions that our computer will execute and potentially, use to create files or send information over some network or things like that. But it's simply a list of instructions at its heart. Now, the computer, the processor, only understands very simple operations such as, manipulating bits, essentially, working with zeros and ones in binary. So there are programs that sit between the processor and the programming language that we engage with. And behind this Jupyter notebook in particular is a Python interpreter. The interpreter is a program that essentially reads the Python code that we write and translates it into a set of instructions that are closer to the kind of language that the processor speaks in or understands. And then there's subsequent programs from there that eventually deliver the instructions in a way that the processor understands. And then these programs receive the results from the processor and translate the results back to us, again, in a way that we understand. And we'll find that the Python programming language, in many ways, resembles simple English. So it's a very different language from how the processor communicates with other parts of the computer. We'll begin with just considering some very simple operations, such as 1 plus 1, which is a valid expression in Python. And by pressing Shift-Enter while highlighting this cell, we will evaluate the statement 1 plus 1, and we get back the result 2 as output. We can also do things like multiplication, and when we do 2 times 3.5, we get back 7.0 as output. Now, we can, of course, if we want to write a computer program, we won't just be evaluating single lines of code, but we'll be evaluating many lines of code, preferably that interact in some way. But very kind of elementary program might be just combining these two simple computations that we've done already, where we'll first evaluate 1 plus 1, and then we'll evaluate 2 times 3.5. And when we evaluate that, we get 7.0 as output, which might lead you to wonder, did the Python interpreter evaluate 1 plus 1? In fact, it did. However, the interpreter can only return a single result as output, and therefore it's going to show us the output for the last instruction evaluated. If we want to visualize the output of each line, instead of evaluating these statements, we could print the results of their evaluation to the screen. So by printing each of these lines, we now see 2 as the result of 1 plus 1, and 7.0 as the result of 2 times 3.5. Now, it's important to note that these print statements are not returning results. They are printing them to screen. And we can notice that this 2 times 3.5, when we evaluated it, returned a result as output. When we printed these results, there's no little out here. There was no returned result. This will become significant later, but for now, we should just keep it in mind. When we're writing longer programs, or combining lines of code, it's easy to get lost in, the complicated interactions of different functions and variables, or if we're working with some obscure part of the language, we might easily forget what we're trying to do. It can be useful to add annotations to our code that explain our thought process or explain what a particular line of code does. For this, we can use comments. Comments are lines of code that are not evaluated by the interpreter, or they are just lines in our program that are not evaluated by the interpreter. Since they're not evaluated, they don't need to be valid code. Here, we have two print statements So we'll first print 1 plus 1 is, and then evaluate 1 plus 1. And then we'll print all done. And in between we have a comment designated by a pound sign or hash symbol or number symbol, whatever you want to call it, to show this is a comment. And the interpreter will skip any lines that are that start with this number sign. So we can use this to comment on code and remind ourselves of what the code is supposed to do. In this case, all this comment says is that it is a comment. And we see that the interpreter evaluated the first print statement, it did nothing with this comment, and then it finally evaluated this print statement that says all done. So we're beginning to build up our capacity to evaluate sequences or lists of instructions, and we're on our way to building a computer program. However, at this point, there's no way for our various lines to interact. There's no way for me to take the information that's returned as a result of evaluating these statements and propagate them forward to subsequent lines of code. For that, we'll need a way to store information. And the way we store information is by creating variables. So I'm going to eliminate this for now. Variables are objects that are stored in memory. Variables have names to allow us to interact with them in the code. By creating the name first result and assigning it the result of 1 plus 1, we create a variable that's going to store whatever is returned by evaluating 1 plus 1. So we're creating this variable named first result. And this allows us to then use that variable in subsequent calculations. So we can take first result and use it to compute final result. And then finally, we'll print out that final result. So we get 7.0, since first result should evaluate to 2, and we multiply that by 3.5. So this is going to allow us to break up computations into multiple stages, or accept information from files or user input, and then propagate that forward through our program. Now, I made this sort of unclear or convoluted distinction between names and variables. At this point, that distinction is not important, but when we start to talk about data structures, that distinction will become more significant. Variables are objects stored in memory. Names are labels that we assign to them. Names are how we refer to variables through code. It can be possible for multiple names to point to the same variable in memory. Again, we don't have to worry about this now, but it'll become significant later on when we talk about data structures in subsequent lectures. So first result is a name that points to a variable in memory. I'll often be sloppy about differentiating between them. If we were creating a program that different users might make use of, we might want variables that store that user's information. So here, I have an example of several variables that will store information about me. To introduce myself, I'm Dylan. I'll be your instructor for the course, and you'll be hearing my voice a lot throughout the different lectures. Currently, at the time that I'm creating this lecture, my age is 28 years old. My favorite number is 2.718, and I have a dog. So I'll create these variables simply by naming them and then putting an equal sign to assign them a value, and then the value that I want to assign them. That value, as we saw before, can be the result of a computation or just simple values that I write out completely. Now, these variables all store different kinds of information. We have some numbers, some text, and even this true value. Python is able to automatically create the variables that store these different types of information. There are other programming languages that require you to declare what type of information a variable will hold before you assign that information to the variable. Python does this automatically for us, and we are free to reassign variables different types of information whenever we want. For those of you who have more programming experience, we might say that Python is not a strongly typed language, or it doesn't have type safety. In other words, Python just allows any variable to hold any type of information. We can explore those types by printing out the results of applying the type function to each variable. So we see my name is of class str. str is short for string, or string of characters. Text, like Dylan, will usually be of type string. My age is an integer, or int. It's a whole number. My favorite number, which is a decimal number, is a float, which is short for floating point number. Floats are decimal numbers. The reason they're called floats is because they take up a certain amount of memory, and the way that we allocate that memory for representing digits of precision can float on either side of the decimal place. So we can allocate more memory to digits on the left or more memory to digits on the right. But for most intents and purposes, you can just remember that a float is a decimal number. And then finally, this true value is what's called a bool, which is short for Boolean. A Boolean variable is simply true or false, and it's represented by a single binary bit. To conclude this lecture, I'm going to challenge you with a couple exercises. You should pause the video, or stop the video. You should pause the video. I'll share solutions to the exercises after you pause. But pause the video now and complete these exercises. The first exercise is to create your own my name and my age variables with your own name and age, and then print them out. Your second challenge is to create a my age, or to use your my age variable to print out how old you will be in 10 years from now. So pause the video, and when you've completed these, unpause it, and I'll share my solutions. Okay, so hopefully you've completed these exercises. I'm going to create a new cell, and I'm only going to show the solution for exercise 2, because obviously my solution for exercise 1 is simply up here. So I created this new cell by being in the command mode of Jupyter and pressing the letter B. I could also click this plus button to insert a cell. Remember that all the keyboard shortcuts for interacting with Jupyter Notebooks can be found in the Help menu. More of that is discussed in the introductory video if you need more help with Jupyter Notebooks. So my age in 10 years will be my age plus 10. And by evaluating that, we see that in 10 years, I'll be 38 years old. I'm going to take it one step further and print out that age as part of a string, as part of a sentence explaining what this quantity is. So I'll do print. In 10 years, I will be blank years old. So I created this blank here with curly brackets. And what I'm going to do is on this, at the end of this string, I'm going to put a dot format, and then I'm going to put my age plus 10. What this will do when I evaluate the cell is it automatically plugs in that 38 for my age plus 10 into this bracket placeholder. This is called string interpolation or string formatting. I'm not going to explain it more in this lecture, but if you're curious about it, you should search on the internet for more information. In fact, many times in lecture, you'll see me pull up Google and look for information. Because while I know a lot about programming in Python, I don't remember the exact way to do everything. I don't always remember the right syntax or the right function that I need to accomplish some task. So often, I'll just search for it. So if I wanted to learn more about string interpolation, I might search for string interpolation. And doing that, I see I get a result from Wikipedia, which might tell me more about what it is in general. And I get some results about JavaScript, C#, different programming languages that aren't Python, Ruby, Scala. And if I want to specifically know about Python, I'll go ahead and add Python to that search. And this second link mentions Python string formatting best practices. Let's have a look at that. And when I visit this site, I see in the table of contents, number 2 says new style string formatting str.format. Well, that's just what I showed here. I have a string dot format. And you can see there's examples here that look like mine. And it goes on to explain what that string interpolation is all about. In fact, there's links to more information about string formatting from the official Python documentation. So get in the habit when you're watching these lecture videos or studying the notebooks of searching for additional information. I won't take time during the lectures to explain every detail of everything I mention. While a lot of the information I may gloss over is in the notebooks, some of it isn't anywhere in the course materials, and you'll have to do a little bit of independent study to supplement what we share with you in the lecture videos and lecture notes. I'm going to conclude this video here, and in the next video, I'll talk about Python functions.